Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to look at some more other trigonometric forms of integration. In the previous video, we focused on using this Pythagorean identity, as well as our double angle identities, to manipulate functions that we needed to integrate. In this video, I'm going to focus on this Pythagorean identity. And I also want to remind you what the derivative of the secant function and the tangent function is. It's important to be familiar with these derivative formulas because recognizing them in the questions that we're going to look at will help you manipulate your integral. So remember that the derivative of tangent of u with respect to x is secant squared u du dx. The derivative of secant u with respect to x is secant u tangent u du dx. So let's take a look at some examples. We're going to take a look at this type of example where we have a product of the tangent function and the secant function with various powers. And there's going to be different approaches depending on those powers. So in this example, if you recognize that the derivative of the tangent function is secant squared, then you can view this as u to the n, where u is the tangent of x, so the du factor will be secant squared x dx. So we already have our du factor exact, we don't have to do any manipulation. We're now going to use the general power formula that says the integral of u to the n du is 1 over n plus 1 times u to the n plus 1. So in this case, n is 6, so n plus 1 is 7. So the result will be 1/7 tan of x to the 7th power plus c. In our next example, we have a secant function, but it's cubed. We have a tangent function without a power. Now I'm going to break that up. I'm going to break secant cubed into secant squared times secant. Now in this example, if I think of this as being my u to the n, my u is secant of x, and the derivative of the secant function is secant x tan x. So I can still use the same pattern, but this time my u is secant of x. So the du factor is secant x tan x dx. I have it, it's exact. So once again, I'm going to use the general power formula, which says this integral will be 1 over n plus 1, n is 2, so 1/3, times the secant of x to the power of 3. So you might have to do a bit of manipulation, remembering what exactly is the derivative of what. Let's try a few more examples where we have to use our Pythagorean identity. In our next example, we have tangent function is cubed, secant function is to the 4th power. Now, what I'm going to do is break secant of x to the 4th power into secant squared times secant squared. And the reason I'm going to do that is secant squared x is the derivative of tangent of x. Now what I'm going to do is I'm going to replace this using my Pythagorean identity. So that will be 1 plus tangent squared x Then what I'm going to do is distribute tangent cubed to each of those terms. You can leave it in this form if you understand that this is u to the n and this is your du. This is u to the n du, but I'm going to split it up into two integrals. So I'm going to have the integral of tangent cubed x secant squared x dx plus the integral of tangent to the 5th power of x times secant squared x. for each of these terms, we're dealing with a u to the n, where u is tan of x, and the du factor will be secant squared x dx. So I have my du factor here, I have my du factor here. So they both fit the general power formula, and therefore I can integrate using that method. So the integral of u to the n du is 1 over n plus 1. So in my first term, n is 3, so n plus 1 will be 4. So it'll be 1/4 tangent to the power of 4 x plus, same process, but now n is 5. So n plus 1 will be 6. So that would be my integral. Let's try a few more. In our next example, we do not have a tangent function at all. So what I'm going to do in this case is I'm going to break this up into secant squared 3x times secant squared 3x. I'm going to replace this secant squared 3x with my Pythagorean identity. It will be 1 plus tangent squared 3x times secant squared 3x dx. And then I'm going to break it up into two integrals. So it will be 1 times secant squared 3x dx plus the integral of tangent squared 3x secant squared 3x dx. This is one of my basic trigonometric forms. Remember, if you have secant squared of u, where in this case u is 3x, so the du factor is 3 dx, I need a 3. So I have my du factor. I balance it by dividing by 3. That's one of the basic trig forms. So the integral of secant squared u du is tangent u. The next term is of the pattern u to the n, where u is the tangent of 3x. So the du factor is secant squared 3x times the derivative of 3x, which is 3. So I need a factor of 3 here. So I divide by 3 again. Now it fits the pattern integral of u to the n du. So I use my general power formula where n is 2. So it will be 1/3 times 1/3, which would be 1/9, tangent to the n plus 1. And then we can add our constant of integration. Let's try one more. In our next example, we have tangent to the 4th power, and we don't have a secant function. But what I'm going to start with is I'm going to break this up into tangent squared x times tangent squared x. I'm going to replace one of these using my Pythagorean identity. So tangent squared x will equal secant squared x minus 1. I just isolated tangent squared. Now I'm going to break this up. So that's going to be the integral of secant squared x tangent squared x dx minus the integral of tangent squared x dx. I'm going to rearrange the order here. So it will be tangent squared x secant squared x. And the reason I'm doing that is because I know that the derivative of tangent is secant squared. So now if I take a look at this term, this looks like a u to the n, where u is tangent of x. So the du factor is secant squared x dx. So I do have a pattern that will fit my general power formula. In my next term, I don't have a pattern that I can use with it in this form. So what I'm going to do is I'm going to replace tangent squared again with 1 minus secant squared x. I'm going to break this into two integrals. So I can integrate this. It will be 1/3 tan of x to the power of 3 minus the integral of 1 dx minus minus will be plus the integral of secant squared x dx. The integral of dx is simply x plus the integral of secant squared x dx, that's one of our basic trig forms, that's going to be tangent of x. So it's a combination of knowing how to split up your powers into the different factors and knowing when to use your Pythagorean identities. And knowing what to do when comes with practice. The key is remembering the derivative of the tangent function and the derivative of the secant function. That will really help you in knowing how to manipulate these factors. So practice these, and remember that when you're faced with an integral that has trigonometric functions, play around with your identities. If it's not in a form that you can integrate the way it is, then play around with your identities, whether it's your basic identities or your Pythagorean identities, or whether it's your double angle identities. In the next video, we're going to take a look at integrals involving the inverse trig form. Take care and see you then.